Welcome to Tungal Online Classes. In previous video, we have discussed the concept of free body diagram and we have solved some numericals. Okay. So today we are going to solve some more numericals on the basis of the same concept. Okay. See here. So in this problem, they are given the two bodies of masses m1 and m2. These two bodies are connected with the help of a light string that is passing over the frictionless pulley. So here the one body is placed on an inclined plane and the another body is hanging vertically downward direction. So here is also we are going to find out what is the acceleration of the system. And what is the tension developed inside the string. Here condition is the m1 is greater than m2. Here the m1 is greater than means the weight of the first body is more comparing to the weight of the second body. If the weight of the body is more means in that case this body is moving in the downward direction and this body is moving in the upward direction, right? Okay. So first one, we are going to find out what is the direction of a tension inside the string. Okay, see here. So this is a point of contact between string and the body, and here this is a point of contact between the string and the body. Then the direction of a tension, it is always away from the point of contact. So this is the direction of a tension. Here is also same, it is away from the point of contact. Okay. So next one, we are going to draw the free body diagram for body A and body B. So for first one, for body A, first we are considering this as a point object, that body as a point object, and the first force, it is acting in downward direction, that is weight, and the tension, it is acting in the upward direction. This is the free body diagram for body A. Similarly, free body diagram for body B. Okay, see here, it is very important here. So in this case, the weight of this body acting in downward direction. So the weight of this body is acting in the downward direction, and the normal, it is always perpendicular to the surface. So then extend this one, and this weight, it can make an angle theta with respect to this one. Okay, the next one, the weight is a vector quantity. It can be resolved into two components. One is the horizontal component and one more is the vertical component. So in this case, the weight vector, it makes an angle theta with respect to this axis means, so this is our horizontal component and this is our vertical component. So then what is the horizontal component value here? The horizontal component value is W into cos theta, that is weight into cos theta, and the vertical component value is, that is W into sin theta. So these are the forces acting on the body B. Okay, see here, we will draw the free body diagram for body B. So first consider, this is a point object, here mg sin theta. So W is nothing but it is a product of mass into acceleration due to gravity. So that is W sin theta acting in this direction. W sin theta, it is acting in this direction. Next one, tension is acting in this direction. This is the direction of a tension, that is T. After that, normal reaction is acting in this direction. This is a normal reaction, and here this force, that is W cos theta acting in this direction. Okay, see here, the body is moving along the horizontal direction. There is no motion of this body along the vertical direction. So along the vertical direction there is no motion means the net force acting on this body is 0. The net force acting on this body is 0 means, so then here the normal reaction, it is balanced by this force. Okay, see here, for vertical direction, the net force acting on the system, that is equal to, here, that is normal minus W cos theta. W is nothing but weight, it is a product of mass into acceleration due to gravity, that is mg cos theta. So in this case, there is no motion of the body along the vertical direction, so the net force acting on this system is 0. So from this one, this value is n is equal to mg cos theta. This indicates that the normal of this body, it is balanced by mg cos theta. Normal of this body is balanced by mg cos theta. Okay, so here we will write this one here, that is n is equal to mg cos theta. N is equal to mg cos theta. So from free body diagram for body A, this is for body A and this is for body B. Okay, from this body, right? So here the condition is the mass of the first body is more comparing to the mass of a second body. So then this body is moving in the downward direction. Then this is the direction of a acceleration. This is the direction of a acceleration. So in this case, the weight of the body is more comparing to the tension inside the string. So then net force acting on the first body, net force on body A. Okay, so net force means that is F net is equal to, net force is equal to weight minus tension, weight minus tension. Okay, see here the net force is nothing but mass into acceleration. Here the mass of the first body is m1 into acceleration, that is equal to weight is nothing but product of mass into acceleration due to gravity minus tension. So this is our first equation. So this is our first equation. Okay, next from this diagram, so in this case there is no motion of the body along the vertical direction, then n is equal to mg cos theta. Here that body is moving along the horizontal direction. Okay, then net force acting on, net force acting on body B, net force acting on body B. Okay, see here. So in this case the body is moving along in this direction, so then the tension is more comparing to the W sin theta. Write down here, that is the net force is equal to tension minus W sin theta, right? So net force is nothing but it is mass into acceleration. The mass of second body is, that is m2 into acceleration, that is equal to tension minus W is nothing but product of mass into acceleration due to gravity, m2 into g sin theta. So this is our equation number 2. This is our equation number 2 and this is our equation number 1. Okay, so next we are going to solve the equation number 1 and equation number 2. See here, solve equation number 1 and equation number 2. So equation number 1 is, that is m1a, that is equal to m1g minus tension, and here this is m2a, that is equal to tension minus m2g sin theta, m2g sin theta. Okay, see here. So add these two equations, add these two equations. So then here minus t plus t get cancelled, m1a plus m2a, take a common. Okay, see here the result of this one is m1a plus m2a. If you take a common means, then bracket of m1 plus m2, m1 plus m2. Okay, a bracket of m1 plus m2, that is equal to m1g minus m2g sin theta. So here this value is m1g minus m2g sin theta. Take g common, then it becomes a bracket of m1 plus m2, m1 plus m2, that is equal to, take g common, g bracket of m1 minus m2 sin theta, m1 minus m2 sin theta, right? Okay, so next from this relation, acceleration is equal to, acceleration A is equal to, acceleration A is equal to g bracket of m1 minus m2 sin theta, m2 sin theta divided by total mass of the system, that is m1 plus m2. So this is the acceleration expression. See here, this acceleration A is equal to g bracket of m1 minus m2 sin theta divided by m1 plus m2. So this is the acceleration of the system. Okay, next we are going to find out the tension. To find out the tension, we are going to substitute the A value either in equation number 1 or in equation number 2. So here we are going to substitute A value in equation number 1. Okay, see here, from equation number 1. Okay, see the equation number 1 is, that is m1a is equal to m1g minus t, right? So in this case we want the tension value, take t this side, then it becomes m1g minus m1a, right? Take m1 common here, then it becomes g minus a. So this is a tension T is equal to m1 bracket of g minus a. So next we are going to substitute A value, acceleration A value in this expression. Substitute the A value in that expression, then tension T is equal to m1 bracket of g minus a. What is the A value here? A value is, that is g bracket of m1 minus m2 sin theta, m1 minus m2 sin theta divided by m1 plus m2 divided by m1 plus m2. Okay, see here, m1 plus m2. So in this case, take g common, then tension T is equal to m1g bracket of 1 minus m1 minus m2 sin theta divided by m1 plus m2. So in the next step, take LCM, then the tension inside the string, that is T is equal to m1g as it is, multiply this one here, that is m1 plus m2 minus as it is, take minus and inside, that is minus m1, minus into minus is plus m2 sin theta, plus m2 sin theta whole divided by m1 plus m2 whole divided by m1 plus m2. Okay, see here, in this case plus m minus m get cancelled, the remaining is m2 plus m2 sin theta, take m2 common, then the tension is equal to m1 into m2 g bracket of 1 plus sin theta whole divided by total mass is, that is m1 plus m2. So this formula we are used to find out the tension inside the string. So in this problem they are given the two bodies of masses m1 and m2. The one body is placed on an inclined plane and another body is hanging vertically, right? Okay, so in this case we are going to find out the acceleration and the tension in the string. Okay, first one, we have to draw the free body diagram for body A and body B to find out the acceleration of the system. Okay, see here, first one, the free body diagram for body A. Here there is only two forces. One is the weight is acting in the downward direction and the tension is acting in the upward direction. For body B, so here the weight is acting in the downward direction and that weight can be resolved into two components. So one is the horizontal component and one more is the vertical component. So horizontal component value is W cos theta and vertical component is, that is W sin theta. Vertical component is W sin theta and this direction is normal and this is the tension. So then free body diagram for body B. The first force is W sin theta is acting in this direction, W sin theta is acting in this direction, and the next one tension is acting in this direction. This is the direction of a tension, and this one is the W cos theta, it is acting in this direction and the normal is acting in this direction. So in this case, that body, it is moving along the horizontal direction. There is no motion of this body along the vertical direction. If the body does not having the motion in the vertical direction, then net force equal to 0. If the net force equal to 0 means normal is equal to, that is mg cos theta. Normal is equal to mg cos theta. So next one, we are going to write the equations according to the body A and the body B, according to the free body diagram of a body A and for body B. Okay, see here, the first one, the net force acting on the first body is net force equal to W minus T. In this case, the mass of the first body is more, so then the weight of this body is more comparing to the tension. So then net force equal to W minus T. Substitute the value here. Similarly, for second body, the body is moving in this direction. In this case, the tension is more comparing to the W sin theta. So then net force equal to tension minus W sin theta. So then solve these two equations. We will get the acceleration value, that is A is equal to G bracket of m1 minus m2 sin theta divided by m1 plus m2. So next we want to calculate the tension inside the string. So then we are going to substitute the A value either in equation number 1 or equation number 2. Solve the equation, then you will get the final result is T is equal to m1 into m2 G bracket of 1 plus sin theta divided by m1 plus m2. Here the next model. So in this problem they are given the two bodies of masses. Both the bodies are connected with the help of a light string that is passing over the frictionless pulley. So here the mass of first body is m1 and the mass of second body is m2, right? So here both the bodies are placed on the inclined plane. So here we are going to find out what is the acceleration and what is the tension inside the string. Okay, see here, to calculate the acceleration of the system, first we have to draw the free body diagram. Okay, see here, for first body A, right? So consider this is alpha and this is the first body of mass is m1, right? See here, the first one, the weight of the body, it is acting in the downward direction. That weight is nothing but product of mass into acceleration due to gravity. So here the mass of a first body is m1, and the normal reaction, it is always normal to the surface of the body. So this is a normal reaction, that is n, and extend this one, it makes an angle alpha with respect to this axis. So then the weight is a vector quantity. It can be resolved into two components. One is a horizontal component and one more is a vertical component. Your horizontal component value is, that is m1g cos alpha, and vertical component value is, that is m1g sin alpha, right? The next one, the direction of a tension. So this is a point of contact, means this is a direction of a tension, and this is a point of contact, means this is a direction of a tension. So this gives the direction of a tension. Okay, see here, so in this case this angle is alpha and this angle becomes 90, and this angle is, that is 90 minus alpha. So then this angle becomes, that is alpha, or the simple. So if this is angle is alpha, means this angle is also alpha. Just remember this point. Okay, the next one, free body diagram. Okay, so consider this a point object, right? So the first one is normal reaction is acting in this direction. Next, tension, it is acting in this direction, and vertical component of weight, that is m1g sin alpha acting in this direction, and here horizontal component of weight, that is m1g cos alpha, right? Okay, so this is a normal reaction and m1g cos alpha. So in this direction there is no motion of the body. So there is no motion of the body along this direction. So then the net force acting along this direction is 0. If the net force acting along this direction is 0, means this force is balanced by this force. So that means N is equal to m1g cos alpha, right? So this force is balanced by this force because there is no motion of the body along this direction. If there is no motion, means the acceleration is 0. If the acceleration is 0, means the net force acting on this body along this direction is, that is 0, because it is product of mass into acceleration. Acceleration is 0, means 0 into any term is 0. So the remaining factor is, that is N is equal to m1g cos alpha. Okay, the next equation, the net force acting along in this direction. Here they are given, the condition is m1 is greater than m2. If m1 is greater than m2, means the mass of first body is more comparing to the mass of a second body. So then the weight of this body is more, means this body is moving in this direction and this body is moving in this direction. Okay, the net force acting on this system, the net force acting on the system, that is equal to, net force is equal to, here the weight of the body is more, so that means that is m1g cos sin alpha, m1g sin alpha minus tension, m1g sine alpha minus tension. So this is our first equation, right? Okay. The next one, we are going to draw free body diagram for second body. See here. So this is the beta and this is the body of mass is m2, right? So the first force is acting in this direction, that is the weight, right? Next, this is a normal reaction. For our reference, we will write that is n1 and extend this one. It makes an angle beta. So then weight can be resolved into two components. One is a horizontal component and one more is a vertical component. Here horizontal component value is m2g cos beta and vertical component value is m2g sine alpha, and this is the direction of a tension. This is the direction of a tension. Okay, see here. Then free body diagram. So here this is m2g sine alpha and this is the direction of a tension, and this is a normal reaction, that is n1, and here this is horizontal component of weight, that is m2g cos beta. Okay, so next, here there is no motion of the body along the vertical direction. This force is balanced by this force. So then n1 is equal to m2g cos beta, right? Okay, so next, so here this body is moving in this direction, means the tension inside the string is more comparing to the weight of the body. So net force acting on the body B, net force acting on the body B, okay, then net force that is equal to, so net force that is equal to tension minus weight, here the weight value, that is vertical component value, that is m2g sine alpha. Okay, see here, so this is a beta, means this angle is also beta, sorry, so this is beta. Okay, so this is our equation number 2, right? Then solve equation number 1 and equation number 2. Okay, what is the equation number 1 here? The net force equal to m1g sine alpha minus t. So net force is nothing but it is a product of mass into acceleration. Here the mass of first body is m1 and acceleration is a, then it can be written as m1a is equal to m1g sine alpha minus t. So that is m1a, that is equal to m1g sine alpha minus t. So second equation is net force, means it is a product of mass into acceleration. The mass of second body is m2 and acceleration is a, then net force it can be written as m2a is equal to t minus m2g sine beta. Add these two equations here, then this becomes m1a plus m2a, take a common, then it becomes m1 plus m2, that is equal to plus t minus t, both are get cancelled, and here this value is m1g sine alpha minus m2g sine beta. So take g common here, then a is equal to, so a is equal to, take g common, m1 sine alpha minus m2 sine beta whole divided by m1 plus m2. So this is the acceleration of the system. So that is a is equal to g bracket of m1 sine alpha minus m2 sine beta divided by total mass m1 plus m2. Okay, next we are going to find out tension in the string. So this is the acceleration of the system, then substitute a value either in equation number 1 or equation number 2. Okay, here we are going to substitute the a value in equation number 1. Substitute a value in equation number 1. So what is the equation number 1 here? That is m1a that is equal to m1g sin alpha minus tension, here we want t value, then t is equal to m1g sin alpha minus m1a. We are going to substitute a value in this equation. So before that one, take m1 common, then t is equal to m1 bracket of g into sin alpha minus a, right? So then substitute the a value here, then t is equal to m1 bracket g sin alpha minus a value is g bracket of m1 sin alpha minus m2 sin beta divided by total mass. So this is g bracket of m1 sin alpha minus m2 sin beta divided by m1 plus m2 divided by m1 plus m2. So then take g common here, then t is equal to m1g bracket of sin alpha minus m1 sin alpha minus into minus is plus m2 sin beta divided by m1 plus m2, right? Okay, so then take LCM here, then t is equal to m1g sin alpha m1 plus m2 minus m1 sin alpha plus m2 sin beta, whole divided by total mass is m1 plus m2. Okay, next tension T is equal to m1g bracket, multiply this one, m1 sin alpha plus m2 sin alpha minus m1 sin alpha plus m2 sin beta, whole divided by total mass m1 plus m2. Okay, so next see here, this is m1 sin alpha and this is minus m1 sin alpha, both are get cancelled, and the final expression is m1g, this is m2 sin alpha plus m2 sin beta divided by total mass. The final expression is T is equal to, take m2 common here, m1 m2g bracket of sin alpha plus sin beta whole divided by total mass m1 plus m2. So this is the tension in the string. Okay, see here, the acceleration of this one is A is equal to g bracket of m1 sin alpha minus m2 sin beta divided by total mass. Then tension inside the string is, that is T is equal to m1 m2g sin alpha plus sin beta divided by total mass of the system.